based from our previous discussions, right, we've already discussed briefly this conduction, right? So as we recall, we say that conduction is a transport of energy in a medium. And what medium is that? Usually it is solid, right? So it is a transport of energy in a medium due to a temperature gradient. So that is the drive for us to have the what we call conduction. So we have a medium and a temperature gradient. All right, so here it is. So once again, when we say the heat transfer through conduction, it is the transport of energy in a medium that is usually solid due to the temperature gradient, which is temperature gradient here is our driving force. Okay, although this conduction occur mostly in solid, but the conduction heat transfer also occurs in say liquids and gases. So we shall not limit our conduction heat transfer using a solid as a medium. Okay, remember that it can also happen in liquids and gases. This is G, that is gases. Okay, so once again, technically speaking, as we can see, the definition of conduction, it is the transport of energy in a medium. Okay, why we usually limit it in solid? Okay, because the problems of liquids and gases is that once they are being heated up, they immediately begin to flow or set in motion, right? So if we can limit their motion, or we can make their motion almost negligible, then we can have this conduction using these mediums or using this media. Okay, so that is the difference, and that is why we are usually have the conduction heat transfer usually in solid. Once again, let us remember that even though conduction usually occur in a solid medium, let us not forget that it can also happen, technically speaking, in liquids and gases or in fluids. Okay, let's move on. So last time we have also learned that the conduction heat transfer is governed by what law? Conduction heat transfer is governed by what law? By, yeah, this by Fourier's law. As you can see, by since that is only an introduction to conduction heat transfer, so we restricted our analysis or our attention in simplified conditions, right? So we have a simplified condition saying we have a analysis using a that is n one-dimensional analysis. We also say that we consider only the steady state conduction and in plane wall, right? So we limit our discussions last time using these simplified conditions. Okay, but in this lecture or in this discussion, we will explore more this a governing equation, which is the Fourier's law, in more detailed way and in a generalized equation. Okay, so let us have the classification of heat conduction problems. So we have classification of heat conduction problems. So, the conduction heat transfer problems that we may face can be classified into the following. So, last time we do the steady state, right? So, we have the steady versus the transient heat transfer. Transient heat transfer. We can also have the what we call the multi-dimensional heat transfer. So last time, as you remember, we've only focused our discussion for the introduction in conduction problems using one dimension, right? But this time, we can now have a multi-dimensional heat transfer. And lastly, we can also classified our problem into say with or without what we call the heat generation. So we have with heat generation or without heat gen. So let's discuss this one by one, these different classifications that we have. So first, let us discuss this heat, steady. This is, by the way, steady versus transient heat transfer. So when we say steady, by the term steady, this implies that our parameter does not change with time. Parameter does not change with time. For example, you have here our we have here our heat flux. Wait. Okay, so where are we? Ayan. So for example, we have a heat flux that remains constant with any time at any location. Okay, so that is an example of steady state condition. So say this is our medium, and we have the heat flux. This is our Q. If this heat flux is not changing from point 1 to point 2, it is said a steady, or in a steady condition. Okay. So if we have here, or we have a like this condition, that our heat flux remains constant with time, say this is a with a certain time condition, then we can say that our condition is in steady state. Meanwhile, as the opposite of this one, the what we call the transient. Let me change my color into orange. So we have a transient condition. Transient, or we can also use the term unsteady. Unsteady state, or transient. So this implies that these parameters now does change or varies with time. So we have parameter varies with time. Okay, so what does it mean? So as we can see here in steady, at any time the Q does not change. So let me have a comparative example. So say we have here the transient condition. So maybe at time 1, our Q or our heat flux is this much. So time 1. But if we analyze it again and compute the heat flux during a time 2, then maybe we can have another value of our heat flux. So it only means that when we consider this frame or this when we consider this medium, say this is our wall, and we analyze the Q for time 1, and that is we have a value of Q, and after some time we again compute the value of our Q, and we have another value of our heat flux. So it means that we have a transient condition wherein our parameter, this parameter here, varies with time. Okay, unlike this one that in any time, so at any time frame or at within certain period of time, our parameter does not change. So we only have one value of Q. So that is a steady, and this part here is the what we called unsteady or transient. So why do we need to determine these two? I mean, what is the significance or importance of these two? Technically speaking, our our actual condition recording our heat transfer is really in this nature, in this transient or unsteady, because for example, at time 1, this is your, say this is your wall, your initial temperature is this part, and your final temperature is this part. Okay, so you have this gradient. So you have this gradient. Then you can have your Q there, right? So say this is condition at morning. Okay, so our time is at morning time. Okay, but when say our wall during afternoon, when we have a higher temperature due to sunlight, then maybe our gradient between the two is much different. Say this is our T2 prime. So at time 2, say this is at afternoon condition, then you can see that you can have a different value of your Q or your heat flux of this same material, of this same wall, right? So so actually speaking, our nature is really in steady state or in transient condition. Okay, but for analysis and simplification of mathematics, we usually use this steady state or steady condition to analyze the heat transfer problem easily. Okay, once again, we have two conditions, the steady and transient heat transfer. So in nature, we have a transient or unsteady condition because our parameter really varies with time. But for some simplifications and to have our to simplify our mathematics better, then we can now consider our condition as steady state.